You are watching Unit 5, Lesson 2 on multiplying polynomials. And that's exactly what we're going to do, is we are going to multiply. In the top right, you can see that there are some steps that we are going to follow. One of the main things that I want to point out is there's a difference between adding, so adding and subtracting, versus multiplying. And that has to do with the coefficients. We're going to talk about that. We're going to multiply the coefficients, the numbers that are in front, then we'll also multiply the variables, but because we're multiplying, some things are going to change. Let's see what I mean by this. Here's my first example, number 1. Very basic. This is a monomial times a monomial. Now, x to the 4th, I could really write as x times x times x times x, x 4 times, times, it's just a bigger multiplication dot, x to the 5th power, x times x times x times x times x. Well, this is really annoying. If we have x to the 20th times x to the 31st, we don't want to have to write out all of those x's. So instead, let's see if we can come up with something to make our lives a little bit easier. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 x's total. I can rewrite this as x to the 9th power. So if I try to make my connection between my exponents up here, 4 and 5, how do I get 9? Well, 4 plus 5 is 9. So the rule is when I have the same base, I can add the powers. Let's see how this looks with example number 2. The first thing that I notice is that I do not have a variable, not that I don't have a variable, I do not have a coefficient of my second monomial. I also have an x without a power. So the first thing that I want to do is write in the power of 1 and the coefficient of 1. Now I know how to multiply. 2 times 1 is 2. Now I know I'm going to have x's. Well, thinking back to example 1, if they had the same base, I added the powers. So 1 plus 3 is 4, x to the 4th. Let's do the same thing with the k's. I have 2 k's here, k times k, and then k times k times k times k times k over here. I have a total of 7 of them. There's my final answer. Example number 3. Now I have a number sitting out, or in this case, not just a number, it's actually a monomial sitting out front of a trinomial. I'm going to write in my coefficients and powers of 1 again, just to keep me in check so I do not forget. A lot of times when we do not write them in, it makes things complicated because we forget to add or we make mistakes. So anytime I have something sitting out in front of parentheses, I need to distribute. That's exactly what I'm going to do. I actually have 3 multiplication problems here. So 2 times 1 is 2, and x to the 1st times x squared is x to the 3rd power. Let's keep going. 2 times 3 is 6, and of course that's a minus 6. I should have said 2 times negative 3. And x times x is x squared, because 1 plus 1 is 2. And then lastly, 2 times a negative 5 is a negative 10. And some people might say, well, this doesn't have an x. That's okay. So I'm just going to carry the x through and write it at the end. And there's my final answer. 4 is very similar to 3. So example 4, I have a's and b's. I'm going to quickly draw in my powers and coefficients of 1 just to have them there. And I have a number, or in this case, a monomial sitting outside of the parentheses out in front, which means I need to distribute. So 3 times 2 is 6. This will be a to the 1 plus 9 is 10 power, minus 3, because 3 times -1 is -3. It seems a little tricky, but it's really not. I have a's, so I'm going to group them together. A to the first times a to the first is a to the second power. 1 plus 1 is 2. And I don't have any b's, so it just comes along for the ride and attaches to that term. Then lastly, 3 times 4 is 12. I don't have any a's, so I will write that. And I don't have any b's to group, so I'm just going to write that. And there's my final answer. Questions like example number 5 usually throw people off because of this power on the outside of the parentheses. I want you to be very careful. So the first thing that we need to do is expand this. I am squaring 3b to the 4th. I'm taking that entire base and I'm multiplying it by itself 2 times. Just like I would if I had 3 to the second power, this would really be 3 times 3. There's my side note. That's all I did here, except I had 3b to the 4th. Now I'm multiplying 2 numbers together, 2 monomials together. 3 times 3 is 9, and b to the 4th times b to the 4th, well, 4 plus 4 is 8. We're going to kick it up a notch in number 6. Because we not only have single distribution, like if I had 3 all times x minus 5, this would be a breeze. But the fact is we have x plus 3 all times x minus 5. So this is what we call double distributing. I need to take my x, this right here, and multiply it by that whole second binomial, x minus 5. Then I'm going to take the plus 3, and because it's positive, I'm actually going to write plus 3, and multiply that all times that second binomial. Now I have all my bases covered. This is why it's called double distributing. I need to distribute the x to the x minus 5, and then I need to distribute the 3 to the x minus 5. Then I end up with x squared minus 5x plus 3x minus 15. Be very careful of your signs. Now, most of the time we are finished, but I see some like terms, so I need to combine those together. I have a negative 5x and a positive 3x, like terms. So this becomes x squared minus 2x minus 15. This is my final answer. Example 7 is just like example number 6, except we have 2 variables now instead of a variable and a constant. We're going to do the same thing. I have to take my x of my first binomial and multiply it by the entire second binomial. So here I took this x and multiplied it by this. Now I'm going to take my negative y and multiply it by that as well. So minus y all times x minus y. And we'll now distribute, double distributing. We'll distribute the x to the x minus y, and the negative y, I'm just going to box that in, to both of those 2 terms. I first get x squared minus xy. I'm going to be careful of this negative, and negative y times x, I could write that as yx, but I'm going to choose to write it, well, first of all, it's minus, and I'm going to write it as xy. It's always best to write the variables in order that you would see in the alphabet. And then a negative y times a negative y is a positive y squared. And again, I could write in all of my powers of 1 to show why this happened, because 1 plus 1 gives me this 2. Now I'm going to write in those coefficients of 1 because I have 2 like terms. My final answer becomes x squared minus, how many xy's do I have? I have 2 of them. And here's my final answer to 7. Example number 8 is very similar to example number 5 because it deals with this power outside the parentheses. The very first thing that I need to do when I see something like this is expand. I'm going to write this as x plus 5 all times itself. X plus 5. That's squared. Now it helps me to see, I'm double distributing again. X times x plus 5 plus 5, all times that second binomial of x plus 5. People that forget to do this tend to get the incorrect answer, I'm going to write this in red off to the side, as x squared plus 25. This is wrong. You have to show that double distributing. That should say wrong. It's running out of space, so it's turning it into a disaster. Okay, now going back to the original problem to finish this off, I'm going to distribute my x times x and my x times 5, my 5 times x and my 5 times 5. So x squared plus 5x plus 5x plus 25. I'm hoping that you are noticing the like terms like I do. Let's group them together to give us a final answer of x squared plus 10x plus 25. Here we are with example number 9. It looks like we kick this up even one more notch, which really shouldn't trouble us too much because we're going to treat this the same way that we treated the previous examples of the double distributing, except in this case we actually have to triple distribute. All right, what do I mean by this? I'm going to take my x and I have to multiply my x by the whole second trinomial. So I took this x, I took this x and multiplied it by this whole thing. So now I'm going to take the minus 1 and also multiply it by that whole trinomial. It's a little bit more work, but it is the same process, which is awesome. Now 1, 2, 3 times I need to multiply, and this minus 1 needs to be multiplied 1, 2, 3 times. X to the third, because remember this is the first power, plus 3x squared, again because that's also to the first power, minus 7x. So this here became this there. Moving forward, we have minus 1x squared minus 3x plus 7. So this became that. Now I need to just check for like terms, and I do have some. I have an x squared here and an x squared term there, so we're going to group those together. A minus 7x and a minus 3x. So in addition to multiplying, sometimes we actually have to combine. Let's rewrite this as our final answer. So x cubed plus 2x squared, just using our integer rules for that, minus 10x plus 7. And remember, when we combine, the powers do not change. It is only when we multiply.